Right, probability now. We'll make this a two-parter. Probability. The probability is the likelihood of something will happen, or it can be the likelihood of something won't happen. Um, a sort of reverse calculation. So probability. What's the chances of something happen? So let's draw this, and this we'll say is a probability line. Yeah, this is the first introduction to probability. And I'm going to divide it up into quarters, and this end of the scale is 0, and this end of the scale is 1. Always, always, regardless of the number of things that you're talking about, it's always 0 and it's always 1. Now, at this end of the scale, things are actually impossible. Yeah? Things are impossible. What could we say is impossible? The probability that we could time travel or something, it's impossible. Um, the probability that you will pass your functional skills level 2 exam could be here, couldn't it? Certain. Yeah, you put enough work into it, remember enough stuff, it's certain. So when it's 0, it's impossible. When it's 1, it's certain to happen. And in the middle, we've got an even chance of something going to happen. So it's sort of, we might coin the phrase, it's 50-50. We've got half a chance of happening. And so we could call that half, couldn't we? Yeah. And this one would be, if we're going to name all these, this would be a quarter, and there's 3/4. And this one will be likely, yeah, likely to happen. What's the chances of the bus turning up on time? Likely, even, depends where you live and what you're waiting for. And this one down here is unlikely, yeah, unlikely. Um, what's the probability of the current government getting us out of a mess? Unlikely. Not, I think it's more on the verge of impossible. But anyway, that's a probability line, and you see that the line that we've got has got 0, a quarter, a half, 3/4, and 1, and that's representing probability as a fraction. Now we can also represent probability as a decimal. So let's have a look at that. So 0, 0.25, remember there's the common ones to remember, 0.5, 0.75, and 1 as a decimal. And the third way we can represent probability is as a percentage. So we've got 0%, 25%, 50%, 75%, and this will be 100%. Yeah, just to convert the decimals to percentages, we're just multiplying by 100. So probability, when you get questions on this, can be in either of these three formats, or any of these three formats, yeah? Right, okay, so let's have a look at the probability, sort of little questions, right? So say we've got 200 boxes in a room, yeah? 25 contain a prize. So the probability of picking a box that contains a prize is going to be this. It's going to be 25 out of 200 altogether. Yeah, and we can we divide that by 25 or 8? Yeah, what, an eighth. Yeah, so it's an eighth. Yeah, so that's as a fraction, an eighth. That's a probability. So sometimes it's written here, probability of, in brackets, what it is, what you're doing, picking a prize, is equal to 1/8. Yeah. Now, if we know that it's 1/8 probability to pick a prize, if we pick a box that doesn't contain a prize in it, what we need to do is do the 200 boxes, take away the 25, and that leaves us 175 boxes with no prize. Oh, so sad. Yeah. So the probability of picking no prize is 175 out of 200, and that will be 7/8. Now, I hope you can notice this, but see this 1/8 and this 7/8. If we add the two together, I'll put it up there, yeah, 1/8 plus 7/8 equals 8/8, which equals 1. And remember our probability line? 1. Yeah? This is all the probabilities added together, always equal 1. So we've got the probabilities of a prize and the probabilities of no prize. Add them together and they'll be the 200 boxes. So the probability is 1 or 100%, whichever way you want to do it. Yeah? Right, okay, so let's go back to our 200 boxes. So we've got 200 boxes. And again, 25 with a prize. Now, remove, let's do 50 boxes. Yeah? Remove 50 boxes and locate elsewhere. So now we want to look at the probability of picking a box with a prize in it from what we've got left. Now, what we've done is we've taken away 50 boxes. So we do the 200, take away 50, equals 150 boxes left in the room. So what's the probability now? Because we don't know whether we've taken some of the boxes with a prize away or not. So we've still got the probability of 25 with a prize. So what do we need to do now? It contains a prize. So how many boxes have we got left in the room? We've got 150 boxes left in the room. So we've got 150 boxes left in the room. And the total number of boxes is 200. So we've got 150 boxes over 200. So what does that equal? Let's have a look. 15 over 20. We divide by 5 is 3 over 4, 3/4. So if we had 200 boxes, let me try and get my head around this one because it's quite, what at first seems quite easy is because we don't know how many there are with a prize. So we can't do 25 out of 150 because some of the 25 have been moved away. So the boxes that we've got left in the room are 150. And we know that it's a percentage, it's like a fraction of the whole lot. So we've got 3/4 is a percentage of the, not 3/4 of, oh, it's not picking a prize. Remember when the prize was still here. This is not picking a prize. This is the probability that the prize, and that's where I've got my head around that, the prize is still in the room. You can't do a probability of what, oh, this was complicated. That's the probability of the, or 75%. There's a 75% chance that the prize is still in the room because you've taken 25% of the boxes away. Ooh, yeah. But it's still 25 out of 100. All the way there. Okay, so let's have a look at some proper questions on this, yeah? Now, Karen checks in for a flight and is given a seat at random. There are 4 window seats, 3 aisle seats, and 9 centre seats. Calculate the probability that Karen is given a window seat. Well, there are 4 window seats. So as a fraction, there are 4 out of how many seats altogether? 7, 16. 4 out of 16. Write your answer as a fraction. So I could write it there, simplify it a bit, 1 out of 4. Now, as a decimal, 1 over 4 is 0.25, and as a percentage, it's 25%. So once you get the first one, so it's 4 windows out of all of them. Right, a garden centre has 1,600 plant pots. They cost £15 each. Paul chooses some of the plant pots to buy at random, spending a total of £300. The garden centre realises one of the plant pots they had on sale was damaged. What's the probability that Paul bought the damaged plant? So we need to find out how many pots Paul bought. Now he spent £300 and we divide that by 15. So Paul bought 20 pots. Yeah. Now, one of the plant pots they had on sale was damaged. So it's one out of 1,600, yeah, is the fraction of the pots. And if we times that by 20 pots, so 1 divided by 1,600 times 20 is 1/80th. Corrected 2 decimal places, 0.01. I don't like this probability. Well, let's have a look. Let's see where we go with this. What is page? We're on page 115. Bear with me a bit whilst I find out 115. Got 115. Got 117. Quarter of 0.01. Yeah. Ooh. Awkward because it was actually 0.0125. So we're losing a lot of the stuff. So 0.01 to 2 decimal places. That's the probability. So the probability of the whole 1 out of 1,600, but he's bought 20 of them. Oh, let's hope this is better. A bag contains only green and orange balls. The probability of picking a green ball out of the bag is 60%. What's the probability of picking an orange ball? Well, we know that it only has green and orange, so those two added together will be the total. So the total is 100%. We take away the green, which is 60%, and so that will be 40% for the orange. More straightforward. Jane has a weighted dice. When Jane rolls the dice, the probability it lands on a 6 is 0.3. What's the probability that the dice does not land on a 6? Now remember, it doesn't matter whether it's weighted or not. Everything adds to 1. Yeah, all the probabilities add to 1. So if we do 1 minus 0.3 equals 0.7, and this is not on a a 6. What? Jane rolls a dice twice. What's the probability it lands on 6 both times? Now, when you do... let's go back to that before I answer that question, yeah? So, the probability of something happening. That's an I, not an E. Something happening. If we say the probability of something happening is 3/4, yeah, this could be seen as our first probability, our first go. Now, if we have a second time, the probability doesn't change. It's exactly 3/4 for the second time. So if you're going to say you throw a ball in a basket or something like a basketball, and you go, well, 3 out of 4, 3/4 chance I'm going to score. Okay, do it twice in a row. What's the probability of scoring twice in a row? So when you have two probabilities, one after the other, you multiply them together. 9 out of 16. So if you threw a dice and the probability of getting a 6, the probability of a 6 is because there are 6 sides, it's a 1 in 6 chance of throwing a 6. If you do it again, it will be a 1 in 36. So you can see the odds, the probability of getting 2 6s in a row, or 2 6s with 2 dice at the same time, the odds get more and more difficult, yeah? If you were to throw it again, so you get 1 in 6 times 1 in 6 times 1 in 6, and this is true for any number, it just happens to be 6 on sides on the dice. So that would be all that times 6 times 6 times 6, I think that's 216, yeah. So 1 over 216, yeah. So the more times you try and do it in a row, the smaller the odds. And this is in fractions, but it will work the same for decimals, which is this one. Jane rolls the dice twice. What's the probability that it lands on 6 both times? Okay, so we could do 1 in 6 times 1 in 6 equals 1 in 36. Now Jane rolls the dice 3 times. What's the probability that it doesn't land on a 6? So if it's 1 in 6 to land on a 6, then it's 5 in 6 to not land on a 6. And we need to do it 3 times. So it's that times that times that, which equals, that's 125. What did we say that was? 216. Yep. So I wonder if I can go 125 divided by 216. No, can't simplify that. So it's about 0.5, isn't it? It's not much. There you go, probability. The second part of the probability is going to be using tables and things. Okay, I'll see you in the next one.